Welcome to our tutorial on implementing stream analytics with Apache Heron. In today's session, we will explore the powerful capabilities of Apache Heron, an open-source real-time streaming engine. We'll set up a demo and walk through each component with live coding examples. Let's get started. First, let's start by understanding what Apache Heron is. Heron is a distributed, fault-tolerant stream processing engine originally developed at Twitter. It allows you to process high-throughput streams of data in real time. We will be setting up a simple use case to demonstrate its features. To begin, we'll need to set up our environment. Make sure you have Java 8 or higher, Apache Maven, and Apache Heron installed. You can download Heron from its official GitHub repository. Ensure that you have configured the paths correctly to run Heron commands in your terminal. Now, let's create a new Heron topology. A topology in Heron is basically a graph of processing components where each component is a spout or a bolt. A spout emits streams of data, while bolts process these streams. In our example, we'll create a simple topology that counts words from a stream text input. Next, navigate to the newly created directory and open the generated src/main/java/com/example/app.java file. This is where we will define our spout and bolt components. Let's begin by implementing a spout that will emit a stream of sentences. Now we have a simple spout that emits sentences every second. Let's implement a bolt next. Our bolt will receive these sentences and count the occurrences of each word. Create a new file named wordCountBolt.java in the same directory. Great! Now we have defined both our spout and bolt. The next step is to create a topology that ties these components together. Go back to your app.java file and update it to include the topology configuration. Now that we have created our topology, it's time to run it. Make sure you compile your Maven project with the following command. This will help ensure all dependencies are resolved correctly. Once the project is built successfully, you can run the application using this command. Make sure your terminal is in the root project directory. You should see the output stream printing the word counts for each sentence received. This allows you to analyze the streaming data in real time. Next, we'll look into exploring what happens when we don't just emit a fixed set of sentences, but rather continuous data flowing in from an external source. For simplification, let's simulate real-time data. Here, we'll modify the spout to read from a simulated external data source. Instead of reading static sentences, we'll generate random sentences using a predefined set of words. This will continuously generate random sentences. As with our previous setup, let's recompile the project and run the topology again. Now, we have a dynamic stream of data being processed. You can observe the real-time word counts being computed as new sentences are emitted by the spout. Let's also consider enhancing our setup with logging mechanisms to trace the data flow and error handling for better observability. Using SLF4J as our logging library allows us to capture the incoming stream data and the running counts effectively. As you run the setup again, observe how the logs help you better understand the flow and detect anomalies. Now that we have our application running smoothly with logging, let's talk about deploying our topology. Apache Heron supports various deployment options including local, standalone, and on a distributed cluster using Apache Mesos or Kubernetes. To deploy in a standalone setting, you'll need to first pack your topology into a JR file. Here is how you can do this using the Heron CLI. Remember to replace your topology name with your chosen name. After packaging, submit the topology to the Heron cluster using the following command. It is crucial to monitor the performance of your topology once it is deployed in a production-like environment. Once deployed, you can manage and monitor your topologies using the Heron UI. The UI provides insights into the performance metrics and allows troubleshooting of any issues your topology faces in a production setting. As we approach the end of our tutorial, let's recap what we covered today. We explored Apache Heron, set up a simple word count topology, implemented a spout and bolt, introduced real-time simulated data, added logging to our components, and discussed topology deployment options. Thank you for joining me on this journey to learn about stream processing with Apache Heron. If you found this tutorial helpful, please like, subscribe, and leave your questions in the comments. I'd love to hear your thoughts. Until next time, happy coding!